6 on your side at 6 starts now.
Good evening. Thanks for joining us tonight. I'm Don Nelson. Idaho is making history this week, all thanks to some of the brightest students in the Treasure Valley. A team from Northwest Nazarene University created the Gem State's first ever satellite. The accomplishment is no small feat. The satellite will lift off aboard a massive Delta II rocket. This exclusive story, 6 on your side's Michelle Edmonds is standing by live near Vandenberg Air Force Base in California. Michelle.
Hi, Don. Good evening, everybody. Yes, we are just outside Vandenberg Air Force Base near Lompoc, California, where that Delta II rocket is going to blast off at 1:47 a.m. Pacific time, so at 2:47 Idaho time. Overnight tonight. We are the only team on the ground here. We were the only Idaho team to be able to bring you this video tonight. This was taken just about an hour ago out at the launch pad on Vandenberg Air Force Base. What you are seeing in this video is a service tower finally being rolled away from this massive rocket. You will see at the bottom of the Delta II there are 9 boosters that will take a giant weather satellite at the top of the rocket into space, followed by CubeSats that are in P-pods underneath that will be deployed. That is what the NNU team has been working on for 4 long years. And needless to say, the go for launch for the NNU team has not always been a smooth ride.
I'm ready.
After 4 long years filled with many decisions, hurdles, and delays, Braden Grimm is more than ready to watch the satellite he helped build blast into space.
Yeah, I'm excited. I don't really know what to expect. I mean, I've never done it before, but I'm excited.
The Melba native can claim a piece of Idaho history few can. Braden, 3 other undergraduates, and 2 professors from NNU make up the CubeSat team.
Every engineer especially needs to have these high-five moments in their life. They need to do something that is brand new that they get to name because it's never happened before.
Meet MakerSat Zero. Its purpose is to test 4 polymers, or essentially plastics, to see how they hold up in outer space.
They're right there.
I mean, they're tiny.
Yep.
The experiment may seem basic, but what they plan to do with the data is truly out of this world. The team wants to find the best polymer to use in 3D printers on the International Space Station. So, in the future, satellite diagrams could be emailed to the ISS, allowing astronauts to print out pieces of a CubeSat, snap them together, and then send them out into the cosmos, saving time and money. For that to happen, MakerSat Zero needs to go into orbit the old-fashioned way.
Can you even begin to put a number of hours that you've worked on these projects?
I have no idea. Too many.
The engineers experienced obstacles and failures along their journey, but they never gave up.
In all honesty, we did need these delays to reach this launch, but ended up working out in the end.
And now they're just days from knowing if their hard work works.
We've designed this stuff to do a certain thing, and we expect it to do that. That would be considered a success for us.
And actually, we will know within about 2 hours of the launch whether or not MakerSat Zero, that CubeSat, will turn on and start sending back data. We're going to be live with the NNU team during Good Morning Idaho tomorrow morning to find out if that happens. Also, if you'd like to check out our Facebook page, I did a live report with the MakerSat Zero team today explaining more about what they're trying to accomplish. You could look at that. Dawn, tonight we are headed to the launch site, where if that rocket goes tonight, as it is scheduled to at 1:47 Pacific time, it will go. But there is one caveat. If something goes wrong, they only have 66 seconds in order to get it to orbit at the right time for that weather satellite to deploy. So we'll know within 66 seconds of the count if that rocket goes tonight. I am live outside Vandenberg Air Force Base. Scott Dorval is going to talk much more about the JPSS coming up live on 6 on Your Side.
All right, thanks, Michelle, and we'll hear from Michelle again tonight at 10 o'clock. And you really do have to be a rocket science to get one of those things up. So the question is, Meteorologist Scott Doyle joins us now, who's been involved in this project from our end. A big rocket for a small satellite.
That's right. You're talking about a CUBE satellite. Why such a big rocket? Well, there's a few CUBE satellites on there, but there's a huge weather satellite that's on there. And she talked about the window. There's a window of 66 seconds to get that satellite in the right orbit, which is key. So you got a big rocket, you've got a small CUBE satellite, but it is that huge weather satellite, which is just immense in size. That's why they need this massive Delta rocket. Now, Michelle talked about these booster rockets here. This is not the exact. We're going to show you this launch of a Delta II rocket. These boosters help get the first stage. They're attached to the first stage of the rocket as it shoots on up. It takes about 20 seconds to get past the clouds, expending most all of its fuel. It's such an expensive venture. That's why this CubeSat here will watch these booster rockets now eject here. They jettison off, and then this rocket just basically comes apart in pieces. In fact, you look at this diagram, you see how complex it is. There's the booster rockets, here's the first stage, second stage, and so the main satellite will go, and then these are the CUBE satellites right here. This has shown some CUBE satellites that were launched from the International Space Station. Again, you see some here that were sent on out. So the weather satellite will go about 28 minutes later. The CubeSats will go after that, and this is an area of technology that is advancing rapidly.
And so it's a new technology. It's something that we're going to be watching for many years out. And one day there might be a armada of CubeSats doing similar capabilities that we have from JPSS. But I think that's going to be many years from now.
Traveling over 17,500 miles per hour. You just saw the weather satellite there. I'm going to talk more about that coming up. It's a polar orbiter, so it will go across the globe here 14 times a day, gathering data. The mission's going to go for a few years, and as Michelle mentioned, just a couple of hours after the satellite is deployed, via their cell phones, they'll know whether or not they're getting data from the CubeSat.